Alright, so picking up, we did exponential derivatives yesterday. Did y'all have any issues with the homework problems or anything like that?
Actually, number 9, I think.
Number 9? The e to the square root of x.
I don't.
Okay.
No, it was 7.
7. So let's go over that one really quick. So 7, we had y is equal to x e to the 2 minus e to the x. So this is one of those where I'm assuming you thought it was a product rule.
Yes.
So it's not, because e is just raised to a number. So e is like 2.7-ish. Yeah. So basically this derivative would just be, you could think about this really as e squared x. They just pretty much always put e in the back for some reason, even if it's just a number. So the derivative would just be e squared minus e to the x. So, yeah. It's one of those where they try to get you like they did with the pi thing. And I feel like e is harder to remember sometimes because it kind of looks like a variable because it's obviously a letter, and then, but it is really just a number, so.
Oh. Can I take like 15?
Yeah, that's fine. Just remind me when it gets close to time to go, because. Why don't you just set that alarm, Melcher?
It almost went off in chapel today.
Oh, no.
Like at, I think it was at
Mr.
9,
Law would have been so mad.
9 something or whatever it was. I remembered like 2 minutes before it went off. And I like just,
Oh my goodness.
we would have built it out.
Alright, so the derivative.
That's what would have built it out in the middle of chat.
That would have been great.
I would have been dead.
That's a fact. Well, I don't know. That pastor probably wouldn't have cared. He probably been like, yeah.
Probably. But
He probably wouldn't have cared, but I'm pretty sure if they figured out who it was, they would not have been happy.
Sure. Yeah.
Alright, so the derivative of ln of x, the way we find this is a little bit different. We have y is equal to the ln of x. So, do y'all remember what undoes a log? Specifically a natural log? Okay, yeah. So an exponential. So I'm going to raise both things, okay? So e to the power that's written there, but the e and the ln is going to cancel, so I just have e to the y is equal to x. Okay, and this is an inverse relationship.
That's a Y.
Yeah. So if we were going to take the derivative of this, we would technically be doing so implicitly. Okay, dy dx, we're finding that. So what that's going to look like is we're just going to treat the derivative of e to the y like we did e to the x, but we have to remember because it's implicit, it's going to have that y prime added onto it. So this is just going to be e to the y prime is equal to the derivative of x is just 1. So then to get y prime by itself, we have y prime is equal to 1 over e to the y. And then, here, let me just differentiate implicitly. Okay, so then we go back up here. E to the y was equal to x, so this would technically be equal to 1 over x. So the derivative of ln of x is 1 over x. So dy dx of the ln of x is equal to 1 over x. Try to make my cloud. And then the chain rule version of this 1 over x, because e to the y was equal to x.
Oh, yeah.
So this is just proving it. You don't necessarily have to know this. It's just, it's their thing. So the chain rule, d dx of the ln of u is equal to 1 over u times du dx. So that's your derivatives if you have a natural log. Also show you the derivatives if you have a log of another base. So the derivative of log base a of x. So there's not like a set in stone, like take the derivative of log base a of x. What you have to do, well, we'll get to there in a second, but how to show what it is, we're going to use the change of base formula. So that says that log base a of x is equal to the ln of x over the ln of a. What?
I went, you know how you have chain rule and all of it clouded? Well, I went to go cloud one and I only clouded half of it. But it's pretty nice cloud, so I'm just gonna leave it.
As long as you can see where it is. Alright, so then from here, we're going to use this, okay, to help us find the derivative. So,
Is that Q?
it's an A. It just kind of got an extra long tail on it.
Well, it was making
There we go.
well,
So d dx of the log base a of x, we can treat this as d dx of the ln of x over the ln of a. Remember, the ln of a is just a number, so we can actually take that and pull that out front. The ln of a is whatever the number base was. So we can actually write this as 1 over the ln of a times the derivative of ln of x. Okay, and again, we're assuming that the ln of a is constant. And then we know from above the derivative of ln of x is just 1 over x. So this is just going to be 1 over the ln of a times 1 over x. So the dy dx of the the log base a of x is equal to 1 over x ln of a. Ln of a is a constant. It's just what, yeah, just the little comment there, so you would remember why we can do that. Yeah, it kind of, yeah. Well, I kind of wrote LA and then needed to throw an N in there, so I kind of just went back and threw the N in there. And then, obviously, like all the others, there's a chain rule for this as well. So d dx of log base a of u is equal to 1 over u ln of a du dx. We decided we were going to do a test on Tuesday, right? Is that what we decided? Okay. I thought that's what we decided. But then some other class, I think I'm supposed to be giving something to them too, and I don't remember what it was. Oops.
So we have like history. It's on Monday. It's like a president's quiz and like movie questions, right?
Sounds exciting. What movie was it? That's one we actually didn't watch when I was in government. We watched a lot of movies. That was not one we watched.
Who was your teacher?
I'm Miss Pruser. Or if we did watch it, I don't remember anything about it.
It was, I mean, it was from like the 40s, I think. It was very slow moving, and I don't know, the scenes were very simple.
Yeah, we watched a lot of movies. It was like, I would say 7 out of 10 days, we probably were watching some kind of movie or show or something.
Reminds me of Miss Haven's class when we watched a bunch of movies. I think one was the what's her name? Joan of Arc movie. And I want to say some people when Miss Milligan still worked here made like a Joan of Arc shrine, like her burning at the stake on the board, and it never got erased or something. I mean, I'm sure it's erased now, but
I remember that.
That's funny.
I remember that.
Yeah, we would watch. But I kind of felt like I learned more by that too, so like, you know.
Yeah. I didn't pay attention to like the first half of the movie because I didn't know what the heck was going on. Because like it was moving very slow, but they introduced everything very quickly.
Yeah.
So like I had no idea what was going on. And it was fun.
Yeah. Alright, so we'll go ahead and do the power rule, and then I might do like 1 or 2 little examples, and then Melcher, you can go ahead and go if you want. Get a couple extra minutes till lunch. So, power rule for arbitrary real powers. If we have x greater than 0, then we write the real power of x as a power of e so if you've got something like x to the n, that's equal to e to the n ln of x. So the derivative d dx is equal to e to the n ln of x times the derivative of, so the d dx of n ln of x. I'm just showing you how we're going to get there, and then it'll just honestly make sense in a second. You've honestly seen this before, and you just don't realize it yet. So we keep that e to the n ln of x times n is just a number. The derivative of ln of x is 1 over x, so it's just going to be n over x. E to the n ln of x we had up here was equal to x to the n. What?
I tried to spell right.
Oh.
I don't know what I spelled.
So then we've got x to the n times n over x. So because of this x being down here in the bottom, we can move it to the top by subtracting 1. And since we're multiplying, we can combine that. And then I would just have n times x to the n minus 1, which is basically what you've had all along as the power rule. This is just showing you a way that you technically get it with exponentials. So it just now you've seen it, where it comes from, other than me just telling you that it's a true statement or showing it to you with the definition of a derivative. Basically, this is all that just did for you. I'll let you get that written down and then just I'll do like one or two examples here real quick, and then tomorrow there's like 3 more examples, and then there's a few problems that y'all can look at and try kind of on your own just to make sure you know what you're doing. As long as you know what the little formulas are for the derivatives, these are probably the easiest derivatives outside of just if you have x to a number. The easiest derivatives to do, and then I may look in the AP review book that I have and just see if there's a few pages for logarithmic and exponential derivatives that we can look at, and then kind of go over that stuff and just do a review on Monday for the test on Tuesday then.
Do y'all play tonight?
Yeah,
Who y'all play
we play Stonebridge at 4 or 4:30, something like that.
against? Are you leaving early then? Are you leaving during physics?
Well, when we're done in physics, I have to go down and like pack the cooler and stuff, but technically we're not leaving till 7th period, like the beginning of 7th period. So when we're done, I might, since I can trust y'all, I might run downstairs and start fixing the cooler and stuff to get ready to go. And I have to go out to my car and get the rest of the snacks for them too, so. Anyways. Alright, let's do an example or two here, and then Melcher, you can go. Alright, 16. So kind of picking up where we left off yesterday. Y is equal to the ln of x squared. So, technicality, I've got a chain rule going on here. So, I'm going to take the derivative of that outside piece. So, that's going to be throw the 2 out front, copy down what's inside. If that was anything other than a 2, I'd be subtracting 1 from it, blah, blah, blah. So, that's equal to 2 ln of x. And then I just have to multiply it by the derivative of the ln of x, okay, which is just 1 over x. So instead of writing times 1 over x, I'm just going to go ahead and throw this over x, and I've got my derivative.
How we multiply it by?
All right. And then 18, y is equal to the ln of 10 over x. So when I go to think about this problem, just to make it easier, I'm going to think about it as the ln of 10x to the negative 1, just because when I go to do because I now have a chain rule. So I have a chain rule of a natural log for the derivative. Okay, that way I can just see it better. I don't see the fractions with derivatives very well. I have to like convert it in my brain. If you can see it, you don't have to do that, but I think it makes it a little bit easier. So, chain rule derivative for a natural log, it's just 1 over whatever is inside the parentheses. So 1 over 10x to the negative 1 times, I'm going to take the derivative of that inside piece. So what would the derivative of that inside piece be?
-10x.
To the what?
-2.
To the negative 2. So then my 10s are going to cancel. Then the fact that I have the x to the negative 1 and then I've got the x to the negative 2, I can actually bring that negative 2, 1 down to the bottom. So adding that So negative 1 plus 2 is just going to be 1. So my answer for this one is just going to end up being, it would help if I was on the pen, equal to negative 1 over x. So, not too bad. We'll do a couple more tomorrow, and I might actually do one of the ones that's like finding the point where it's tangent or something like that. It's the same process as you've been doing all along. If you can find the derivative by this point, I would hope you know how to find the tangent in the normal line. It's not like it's anything new. It's just the same thing with a new concept of derivatives is all it is. So, anyways. So we'll wrap those up tomorrow, and then